I'm sorry? Stephen. Hi, Stephen. How are you today? So it's first time being here? Yeah? Cool. Excellent. Thank I was here earlier this morning and I had a talk about some of the 3D printing stuff that I've been working on with their family. They're film crew. Now I have in front of me is Monica, who's been manning the booth. The reason why I said really because now that but purchasing the booth by herself. Great. So I was wondering if she had invited me to Stanford on Thursday, and she's talking about the purpose of the makers. As soon as she's done talking, actually, I tell you what, I'm going to skip over. Kenny, you want to give me a brief interview?
Yeah, sure, let's do it.
Great. So hi, we're speaking to Danny. He got something extremely fabulous. In fact, I tried to get you on the show. We didn't connect, however, we connected here at Stanford. So what have you done? What is this thing?
Yeah, so like you said, I'm Danny. I'm one of the founders of BioBots. We build this device over here, and it's a 3D bioprinter that prints 3D living tissues. And we don't just build the devices, we actually build the software that goes with it, and some of the ink that go into it. And the key here is that, I mean, with this technology, there's an additional challenge on top of traditional 3D printing. And that challenge is that you need to be able to cure materials or turn them from a liquid into a solid without killing the cells. And that's the inspiration, is we developed a new process that allows us to do that. The applications really are, I mean, people always like to think of the future where we really have patients with organ failures and develop new replacements for them. But the reality is that we're far from that goal, and these devices are enabling us to begin getting closer and closer to that. And so a lot of our early clients are really academic researchers at some of the leading tissue engineering and regenerative medicine institutions around the world. And the applications that we're really most excited about now are using the devices to print miniature organs built out of human cells for developing new drugs on, and really testing, instead of using animals or in places where we simply don't have good animal models, using this technology to build models out of human cells and using those models to test drugs and really reduce the cost of bringing new drugs to market.
Very cool. Well, as mentioned, I had the opportunity to get a sneak peek at this on Thursday. And so this is the unit there. I'm going to point the camera down to it. Can you kind of give us some details of it?
Yeah, so to walk you guys through how the device works. I mean, the device itself is really, the key thing that we've done is we took something like these devices used to basically fill up entire rooms, and we shrunk them down into something that fits on your desktop. And it looks similar to most traditional 3D printers, a 3-axis system, so this guy moves in X, Y, and this bed moves up and down. There's a syringe in here, and there's a syringe in here. So this syringe is what has your solution of biocompatible materials and cells, and the extrusion of the material is controlled by compressed air. So compressed air source this plug over here, which you would then regulate with this regulator, and that's how you control the extrusion of material. And so different materials, different tissue types would have different pressures that you need to extrude at. And that's basically how the device works. The key thing is that the process that we use uses visible light to cure the materials, and that's what we do without killing all the cells. And so there's a set of LED tiles in here that shine on the material, and as soon as it extrudes out of the syringe, out of the needle, So the light shine on it and the material appears, basically going from a liquid to solid without killing all of the cells.
Yeah, that seems to be the special thing about it, is you figured out that by using a safer light source or light spectrum, you can actually have more, what would you say, tangible cells or more growth, correct?
Right, so I mean, it's traditional technology, like existing methods, use things like UV radiation, which mutate or kill cells altogether. So by using visible light, which is less harmful, we're able to get some more, basically less mutation in constructs, and, and as you build, as you're building larger and larger structures, that becomes really important. And also, the other key thing about it is that the chemistry is modular, meaning that it works across a variety of different tissue types. So not just not just cartilage or not just liver tissue, but also like heart, lung, bone, even the brain. I mean, the devices are being used across a wide variety of different tissue types, and it's great to see, great to be able to seed the field with technology that's accessible and sort of create a sandbox for people to begin developing and really push the technology forward and push the applications forward, which is really the exciting part here.
Yeah, that's really cool. So one other item, you mentioned some prices in the presentation the other night. And reflect those again.
Sure. Yeah. So really the current model we've been working with Device under is a partnership model with researchers. Like I said, mostly academic researchers right now, and for that, basically we like to. The goal for us is to begin getting feedback on the device. So this is our first product, and we're trying to figure out what works on the device, where the limitations live, where we have to improve on. And so by selling at a low cost right now, it's starting at $5,000. We're able to really getting feedback from researchers, people who are really pushing the envelope and what's possible with the technology, where the field is, and we're going to push it forward. So not only does it create a library of information for us to know, like, hey, like this is the landscape of tissue engineering. These are the applications that are closest to maturity, so those are the ones that we should focus on. But it also just gives us feedback on hardware, like where exactly, like, you know, where can we expect this to be in the next 5 years? Where can you expect to be in the next 10 years? And how can we accelerate that? And that's really the focus here for us for this first product.
Wow, excellent. And if I remember correctly, you have a little kit of collagen. And
so we actually just released, last week we just released our first cartilage kit. It's just like part of the feedback that we've been getting is that, you know, material science, part of this is hard. It's really hard. And unless you're a material scientist, as of basically up until last week, you wouldn't be able to use the technology because you need to formulate your own materials and figure out which concentrations of which chemicals, and you know, it's just like a lot of stuff to figure out. And unless you have the materials science background, it's just not practical.
Yep.
So our approach to this is say, okay, we're gonna put all the material science background that we have to work. We're gonna develop standard inks for different tissue types that users just need to mix their own cells into. So these materials, or these kits that we're envisioning, are really just different biomaterials mixed together with our initiator that works with the visible light, and sort of creating the standard bioinks for different tissue types where users just need to mix their own cells. They just need to add their own cells in, and that's how you keep the flexibility of, say, like, you know, there's not just one liver that we build. Like, everybody has their own liver cells, which are genetically different, epigenetically different, and they just behave very differently. So we need to be able to keep that diversity while standardizing some parts of it to make it so that people can innovate in the space. And so last week we released our first of that line, which is our cartilage kit. It's we're just getting started beta testing it, so we got some good data behind it, and we're starting to work with researchers who are in the cartilage space to really prove it out for us, prove it out with us, and show that, hey, this is a good alternative for people who don't really have the science background. And it's something where, with just a device and these kits and your own cells, you can begin to prototype cartilage tissues and begin to actually make some innovations in the space.
Obviously, it's very exciting. As mentioned, I wanted to get you on early.
Yeah.
Maybe we'll do a more formal or have you as a guest crasher to talk about the progress with it. So thank you, Danny.
Cool. Yeah. Thanks so much.
You going to be talking with them? You want me to just fill in while you're doing it? I'll go ahead. Here, take my microphone. We're talking now. What? Oh, that's fine, but I can't hear theirs. I was going to piggyback on your interview. Can we? I will point it at her. I will point it at her. Okay, will that work? I'll come back later, Monica. Hi. Would like to do a little interview with me. I actually did an interview with John Scholl about 6 months ago on all things 3D, so I'd like to know what's going on. Maybe you can kind of tell us what you're doing here. Would you like to do that for me?
Oh, sure.
So hi, I'm Mike Balzer from All Things 3D, and who are you?
Hi, my name's Allison Berman, and I'm representing the Tech Museum of San Jose. We're collaborating with Enable to use the 3D printers that we have in our fabrication lab so that we can print as our demonstration pieces. Why not make it something useful? So we're printing these hands. We've hooked up with a local matchmaker who sends us files customized for a local kid, and we send them out.
Very, very cool. So how many have you done so far?
Just 3 so far.
I know that's the sad thing about 3D printing right now, but hopefully that will improve. I actually have an Ultimaker too. I'm the guy next door who printed his wife's skull. So
What?
my wife's skull.
Oh, wow.
Yeah. So there's a story behind that. Make Magazine did an interview about 3 months ago, and I'm actually going to be on there live with them. But I am a big fan. I was actually, John Scholl was in my audience at South by Southwest. I was a moderator for a panel there. So it was an honor to finally meet him. So this is kind of neat. So essentially they're going to be able to come by and pick these up today.
Yeah,
So,
they can pick them up. We have matchmakers who help get them to where they need to be.
okay.
We also have there've been remote build-a-thons. There've been remote build-a-thons also. So in areas where we don't have a local matchmaker or convenient person to deliver, we'll send out a bunch of parts. We'll get a community of people to build them as a group. So it's a wonderful bonding experience as well. And the community is always growing. We're always looking for more volunteers to join the Enable community. And even if you don't have a printer, you can always volunteer to help design and modify a design. There's always innovations happening in that space. Better binders, better elastic.
Wow. Yeah, it's really, really exciting. Oh, you're making some little ones over there? That's kind of neat. I see the little tiny hands over there on that printer there. So what varieties do you have here? Are they just custom? Are they all the same Enable hand with some, or?
It started out with one hand. It started out with the hand, the Cyborg Beast, and from there, other people got involved. People actually had someone they were making for, and they started making variants. So there's a kid who, he and Dad have been working on one called the Talon Hand.
Yes, I'm familiar with it.
Yeah, so they're all different. We've got ones where they're meant to fit over a riveted piece of leather bracer. There's ones like the one we're printing right now, the thermoformable one. So for someone who has a differently shaped palm, it really helps provide a custom fit socket because all you have to do is thermoform it.
Mm-hmm.
You can print it flat, which makes it faster and easier to print too.
Wow. Very cool. Now, there's a reason you have Ultimaker printers, right?
I believe Ultimaker donated these.
Yeah.
Ultimaker is a part of Enable, so they have rolled these out to us.
Go ahead.
Yeah, Ultimaker is a partner with Enable, so they've loaned these machines out to us, but they've also worked with us on previous projects. So they're a friend of ours.
That was a loaded question. I'm also friends with Eric, the CEO of Ultimaker, so I was aware of that. In fact, he came on my show about it. But no, it's very cool what Ultimaker's doing. It's really cool what you guys have been involved with. Like I said, I've met John Scholl personally. There's a 3D scientist of Autodesk now that used to work with them. That I think one of these designs, the Talon, is his design. Adrian or Adreesen or something. I can't remember. It starts with an A. It's pretty neat how close this community is and how open at the same time.
I didn't quite catch that. It's a little noisy.
Oh, that's. I have feedback, so I'm probably toning myself down. So what I said is that I've met another gentleman that's the scientist, 3D print scientist for Autodesk, who worked with John Scholl to create the Talon. So I think his name's Andreas.
Yeah.
And he was on my panel at South by Southwest.
Okay, yeah.
Really
so I was
bright
at South
guy.
by Southwest too.
Were you? So you remember me then?
I do remember you. You do look familiar.
I'm the moderator of that.
Yeah,
that panel.
I'm behind the scenes. I let John and Andreas be in front of the camera. So.
Oh, okay. So were you in the audience though?
Yeah, I was in the audience.
Okay, I thought you looked. You were up front, weren't you? Yeah. It's funny is that you're worried about so many other things that you have to. Okay. Well, it's really great what you guys are doing, and it was really a surprise to have John in the audience. So thank you very much.
You're very welcome.
Bye. Oops. Hi. I'm Mike from All Things 3D, and why don't you kind of let me know what you're doing here?
Okay.
You got some pretty cool stuff over there.
We are.
Hi, how are you?
He's a leader, and he speaks very well.
Okay. Hi, how are you? I'm Mike Balzer from All Things 3D, and it looks like you got some really neat stuff there.
You want me to just explain everything?
I'm sorry?
Do you want me to just explain everything?
Yeah, go ahead. Uh-huh.
So, should I start?
Yeah, actually, and by the way, we are live right now.
Oh, sorry. Okay.
No, that's okay.
So, we are from Galileo University in Guatemala,
Oh, okay.
and Guatemala has a history of there was a civil war, so it lasted like 36 years.
Mhm.
So there's a lot of people that still like have amputees or don't have limbs. So we thought, okay, maybe we can solve that problem. So we designed this hand. This is a 3D printed hand.
Uh-huh.
This is actually the hand that is used by an ex-soldier in Guatemala.
Oh,
I took his hand. So how this works is, he just puts this on. This is very low cost. Like this is under $50.
uh-huh.
A normal prosthetic, like a hook device in Guatemala, costs like $2,500. So this is much cheaper, and it looks like a hand.
Yes.
So how this works is you just put it like this, and then when you do like this, like you're gonna break your shirt. So for example, on this position, you can carry back,
Oh, uh-huh.
and you can carry it back. So this kind of position for carrying objects. He's been using it for approximately 8 months. And I do this rotation. So here I press this, do the thumb rotation, and now I can grab like smaller objects.
Oh,
So
wow.
for example, if I wanted to grab this little card, I would just put it like this. And then there. I grabbed it, right?
Wow.
And let go. So this is very low cost, and it works. But then we had another patient. So this patient, he puts a glove on, and nobody notices he doesn't have. But he can write, he can drink coffee, he can do a lot of things. But they said, okay, we had another patient. This other patient, he wanted a bionic version.
Uh-huh.
We started designing the bionic version. So this is the bionic version. So this one, it's a hybrid. So if he doesn't want to use the bionics, he would just put it and activate it just like the other one. So when he does like this, the hand closes. But the thing is, you don't have perfect movement. So if you want perfect finger movement, then this is the one to use. This is still low cost. This is under $500. A normal bionic one is like $45,000.
Yes,
so it's
I know.
much cheaper. Everything is open source. Do it yourself. We designed some of the electronics for this.
Okay.
For example, this is the chip that the circuit that we designed that reads the muscle data. So, and you can download this at Oshpark and then just build it yourself.
Okay.
Um,
So if somebody wanted to find out more information, what's your website?
yeah, Turing.galileo.edu.
Okay.
Can give you that, but Turing
Yes,
as the scientist Turing.
Okay.
Galileo as another science. So Turing.galileo.edu. This is the hook that he used to have. And
It's just a microphone.
And he hated this hook.
Yeah.
Like he was always, his hand was always in his pocket. So we just took out this and we used the screw. And now, like, this is the hand that we gave him. So this has all the motors. This reads my muscle data. So, for example, activated. Okay, so there, when I do like strength, it reads the muscle data and it transmits it to a computer. And this computer has like various modes of operation. So there, I'm closing. I can select, for example, I can select the point. So now when I close, it's gonna do the point.
Oh.
It can do, for example, a pinch.
Now that looks like it's made to fit around your around your wrist, or that way you can access it. The panel there.
Oh yeah. Now the panel can go like on the other hand, so he can select, or it can be like a watch, so he can select things there. And actually, I can go like to the speech mode. So now it has various languages. I can speak in Spanish, English, Japanese. I'm gonna do the demo in English. So I just tell him some numbers. So for example, 1. My English not so good. 1. There's a lot of noise right now. I'm gonna try it again. 1. There. So now it does the 1. Or I can tell him, like, I can give him voice commands and he will understand them.
Oh, very neat. So then it will provide
For example, like a mouse click. I can tell him mouse click, and then when I do this, it activates the action.
Oh, very interesting.
And it also has an AI mode in which I can configure it like the patients, they don't have a hand, but they still remember how it felt to point or to do number 3 or whatever. So they just start training the AI.
Yep.
And once they train it, for example, if I do like this is configured for 1 action. So this is 1 action. This is pinch. So I just like, I'm doing like this. If I like, I'm normal again, and then this executes another action. So we just configure it to different actions. Yeah, and also there's a per user. Like every user has to train it by themselves. So the patient starts training the machine, and the machine, like, they both learn from each other. And actually, they started first like an engineering problem. So we were like all focused on how to fix this and that. But the first time that we used it on the user, on the patient, that was like a very important moment for us, because we kind of like saw how it actually changed the world, the life of that person. This, for example, the guy had a motorcycle accident, and that's why they had to cut his hand off. And he was having some problems that he said that the nails were hurting him.
Because phantom limb syndrome.
Yeah. So with the hook, he couldn't like open them. And when we put this on and he managed to open it, then he was like, wow, the pain went away. So the visual cue of opening his hand helped him with the pain.
I don't know if you're familiar with the study by Ikebani, where the mirrors.
Yeah.
So it seems like this would be the next step, where you could actually control it, and then you would rewire the neurons in order to see it. Excellent work.
Yes.
So have you talked to Ikebani?
To who?
Ikebani?
No.
He's the lead researcher in phantom limb syndrome. Talk to him if he's not already doing it himself. But this obviously is a low-cost solution.
Yeah.
It's IACCOBOINI or something.
Okay.
Well, I'll give you my card. Get with me. I talked in the past. Be very interested.
Thank you. Yeah, because it like the first time that when we saw his face, like our patient's face, that he had hand again, he was all excited. And actually, if you see this hand, it doesn't look human. It's a cyborg hand. So now, like, his Facebook profile is a T100 from Terminator. So like, he's proud of wearing it.
Yeah, well, that's what the kids enable. They're proud of it.
Yeah.
So that's what's happening. In fact, if I lost a limb, I'd be proud of it. What's funny, I do 3D scanning and thought, well, we can scan the other hand or arm and then just model that to create a lifelike. But people don't want that. They like the cyborg.
Yeah. So like the other patient did want like the
realistic
natural look, but this other guy, he was like, no, I'm proud of it. And when he uses the hook, he hates it. But when we gave him the bionic version, he's like, like I want to show this off, and he's okay with it. So we think that that's also important. Yes. All of this open source. It's you can just download the file, build it yourself.
One hand is okay.
Huh?
If required, one hand should be okay.
Yeah. Right now it's for people that have lost one hand. Yeah. Yeah. And also, like, we're adding other stuff. For example, we're thinking, okay, how is he gonna use his remote controller? And with that, we don't need to like add that functionality. We can just insert an infrared like transmitter, and then he can just like go into TV mode and just switch channels, volume, like that. Or we can connect him to the internet or whatever. Like, so he doesn't need to, like, for typing, he doesn't need to actually type. He could just like type with like Morse code or something like that.
That's like the people that are doing the studies by eye movement.
Exactly.
In fact, what's the name of the scientist? I can't think of now. The one that was it cerebral palsy that completely lost. His name escapes me, but he's the famous scientist, mathematician, astronomer. It doesn't matter. They made a movie about it. Yeah. But he used a similar type of system as well.
Yeah. So, I mean, we think that there's a lot of possibilities.
Stephen Hawkins.
Okay. Yeah, okay, yeah. Yeah, there's a lot of possibilities what can be done with these technologies. I think that since it's open source and so people are collaborating, things are speeding up a lot. So we're from Guatemala, we don't have a lot of resources.
No, but we're a small worldwide community now. Yeah, totally agree with you.
But we're able to build all these things because everything is cheap. And actually, we think that since we can build so cheaply in Guatemala, anywhere in the world you can build it cheaply too, which is good. What it used to happen was like something would break and they couldn't fix it themselves. Now, since they built it themselves, they know how to repair it. So I think that's going also in a different direction.
Yeah. Well, thank you very much for the overview.
What's the raw material of that?
What?
Raw material.
What's this area over next door? Is that yours?
That's ours too.
Okay. Yes, please. That looks obviously grabbing a crowd.
Yeah. Yes. Actually, that's one of the things that I like that we're working with hospitals. So this is not like a maker thing, do it yourself. I mean, yes, but
here, go ahead and keep. You can go keep talking.
Okay, so because the thing is, we think that the patients are not just they're going through a lot. Like one of our first patients, he said like he was on to it and he wanted to test it, but then he didn't come back. So we called the wife and asked him, he didn't come. So what happened? She's like, no, like he's feeling very depressed and he's just been drinking all day. And, like he didn't come back home either. Like I don't know where he is. So I think that they need a lot of other things like a psychological assistance and everything. And so for the myoelectric, there's a machine that the doctors have that they just put, and then they examine what are the muscles that are like the most active muscles. So we use that information to know where to put it, because since they're amputees, when they cut them, like a lot of the nerves get moved and everything. So yeah, yes, exactly, and yeah, and that's per person, and how they move and everything. It's for every individual, especially for amputees.
So is there somebody else over there, or do you have another representative over there?
Because we just put the sensors in that part. So and also everybody has like for example, depending on his job, he has different uses for the hand.
Okay.
Yes.
What's that?
You want someone else?
Oh no, you can go ahead.
Okay.
It looked like you were.
Okay, so let's start on the other.
Okay.
Way. Oh, sorry. Okay, so this seems it's pretty popular.
Yes, it is.
Sorry. Here we're showing off the Oculus Rift, which is just like a virtual reality. So the thing with the Oculus Rift is that it's headset that you put on, and then maybe you can approach there and see a little bit, but like they feel that they're going through a roller coaster. So I think that one of the things about virtual reality is that if you go to a 3D movie, you don't feel that you're there. And I think there's a sense of, I'm not sure what the word, that you can control your surroundings. So if you don't get that, you don't feel that you're there. So you have to be like immersed into it. So you look up and you see sky, and you look down and you see the floor. So that's very important. So we grabbed some of those ideas. There we have another exhibit that you are using just a card. So the cardboard is I think it's like under $5 maybe, or $10. It's just a cardboard, electronics. No, just some lenses and a magnet. And so you just put your mobile phone inside, and that's augmented reality. So they're seeing something when they see that image. So we have those ideas, and then we have the robot. So maybe you can go and see the robot there.
Okay.
That's a humanoid robot. So using the Oculus, he's wearing now the Oculus, and however he moves his head, since that sense of, I don't know the word, but like moving and changing the world, that's how the robot moves. So he sees through the robot's eyes. The robot has like high definition webcams, and so he's seeing through that. And the pitch, yaw, roll movement from the Oculus is translated into the servo motors of the robot. You can see that the robot also has a hand. So we're using a leap motion to detect the movement of the hand. We also have like a glove that you put it on, and maybe if you come closer.
Sure.
So there's the glove, and it uses some flex sensors. So maybe you can see it here, but yeah. So those are flex sensors, and it's attached to a hand. So however you move your hand, that moves. So what we're building is you can put a suit on, and then the robot is going to be at my they're going to be at my job. So I'm not going to go to my job physically. They're going to wake up on the Oculus and put on this special like suit, and then the robot is going to move exactly as I move. So right now it's a telepresence robot. I don't have to be there. Or what are the applications? For example, in Guatemala, there are some places that are very, very far away. So we can have the clinic of Dr. Robot. So a doctor in Guatemala City, could just use this suit and examine the patients. And for example, if he doesn't know, like he says, maybe you need an expert on this other thing. So he would just like transfer the call to another doctor who has all the suit on, and then he will.
Wow, that's interesting.
So those are some of the applications. And for like further, like after, since the robot is learning all your muscle movements and all your vision and all your auditory system, then you can like show him how to do things. So for example, you can just start sweeping your home every day, and then the robot can learn, oh, so this is sweeping. And then maybe after a year, he can deep learn those behaviors, and then you can just like download the sweeping behavior, and now he learns how to sweep. So that's maybe for the future, but right now we like, you can see that how he moves is how the robot moves, and other people are manipulating here the hands. So yeah, this is the telepresence robot that we've been working on this for like 8 months. So that's the InMove robot, by the way, which is designed by a French guy named Gael.
I thought it looked familiar.
Yeah, so you just download the files and 3D print them.
No,
So
we're
it's
really,
cool.
in fact, we need to get together. I am working on a VR system using the structure sensor. So that way you have environment awareness, so you can walk around. That's what I'm also a developer, and I have a lens system. So if you're into 3D scanning, look for the structure sensor in my product. So I'll give you my card, and we can have more dialogue.
Thank you. Yeah, because we also have some augmented reality things. So when they were seeing this, when they saw a certain image, something will pop up. And I think that that's very interesting, because one of the applications of this is this one. So yeah, you would have to see through the glasses, and when you see that image, something pops up, and you can interact with it just with your hands. So one of the applications that we're thinking for this is, for example, I have a baby, So when we were going to the, they would scan, you know, but you can't really understand it. It's just like a black and blur. And now there's like 4D, but you can't really understand what's going on. Like, it doesn't look very well. So instead of that, you just put these on and look at your baby. I mean, get the information and then look at your baby full color. You can like get closer to him, rotate, and you can see him like everything. And even a doctor might, because here, right, we have a car, for example, a Lamborghini, and then you, using a controller, you just like make it bigger, and then you can make a life size and see how it would fit, for example, in your house. And then you can go inside and look at the controls. Or we have a house, you can make it like super huge, then go inside the house and walk inside the house you're gonna buy, for example. Or you could like have you have your living room and you want to buy something from anywhere, and then you can just like browse their catalog and see, okay, with this sofa goes up in my bedroom, and then you can see, oh, it's nice, it's the colors, you can change the colors, and then okay. So yeah, those are some of the ideas and projects that we're working on.
Got a lot of stuff going on.
Yeah.
Kind of like my mom.
So
let me give you my card real quick.
Thank you. Hi everyone.
Hey.
Wow. All things 3D.
Thanks. So, and actually, I'll invite you on to a card or a brochure. Thank you. Hi, how are you?
What's the Logitech camera end up being used for?
I'm running a Google Hangout stream live, which is coming through here on a Windows tablet because it's the only thing that allows me to launch it. And then I have an archive standard Canon. It's a Pro version small camera for archiving, and then as additional footage if I need it. In 1080p, this is 720, and then there is a 60 panoramic camera.
And where are you storing this, or are you broadcasting 3D also?
Not yet. Nobody provides that service yet, but that's what's going to happen in the future. Hopefully soon. I have to offload it and bring it up. I'm glad that YouTube supports it now, but they modified something so they're not two-cylinder portraits anymore. They have two curvature. But yeah, it's still a neat representation. I have an LE modem there, USB right here. Thank you. No, okay. Well, actually, on the front of it, it has it as well. So. Yep, C920. Correct. Correct. And a Zoom H5 audio. And actually, this is a Micro Center, 8-inch tablet. Well, what's important is it has a separate USB port. Most tablets don't. So it has two USB ports instead of one.
Okay. And all things 3D. Let's go your site too. Nice job. What's your name?
My name is Mike Balzer. I'm the producer and also the founder of Slow Creator. Welcome. So, and then I have an additional battery back here that runs about 6 hours. And then if I forgot the cable today, I've got two LED light strips here that provide additional front lighting.
How bright does it get?
Huh?
How bright do the light strips get?
About 1,200 lumens.
That's impressive.
Yep.
And where did those come from? Are they just
Believe it or not,
together?
they're actually car lights.
Oh, okay. So Snap-on has a little portable rig they're selling at Costco, and I thought maybe a.
Well, I've got some of those too, but no, these are just strips. Well, yeah, exactly. They're not as bright, and these are 12 volts. So I have an additional power pack to supply, but I forgot a piece to it. But luckily, we've got diffused lighting, and we're pretty good today. So it worked out. So thank you.
Have sponsors, advertisers?
Nope, do not.
Hobby?
No, I wouldn't say that. I put too many hours in it, but we've been doing it an hour and a half.
Okay.
I've got a co-host, Chris, and we do a weekly show called 3D in Review, and then we do several interviews and play roundtable discussions on 3D stuff.
Good. I'll check you out.
Thank you.
Nice job.
Thank you. Hi.
What are you showing here?
Actually, I am showing you right now. This is a live streaming system with Hangouts on air with additional backup as well as a 360 panoramic camera. So what I'm doing is going around and interviewing people.
I see.
So thanks. I'm streaming the event through Google Hangouts, and also I'm capturing full panoramic. That's what that camera's for, and talking with people. So right now, it looks like we are in the Supercharged Science area, and again, like many things here at MakerFaire, they're very family-oriented. So bring your kids, come in, and enjoy the experience with them. I think this is super important. I wish when my children were younger, things like this existed. Obviously, pretty much if you look at it, is people taking things that they experience with their children, hobbies and so forth, and making it available for a larger group of people. So we're going to take a quick spin around here, and then we're going to head out to another area. So we are in the major tent pavilion here, where a lot of the 3D printers, as you see here, it's a personal CNC. Actually, let's see if we can get in there and talk to them. Actually, these are the same people who saw it. I'm sorry. It's a live streaming broadcast system. I'm sorry. Well, that's my goal, and right now it's streaming live. Actually, work. So tell me, I think, were you guys at Real 2015?
Do it again?
Were you at Real 2015 with your CNC? Okay, so this is another one. What makes it special other than personal CNC?
Well, essentially what it is, this is a mill that's capable of anything that a full-on production industrial mill might be capable of. Whereas, here, there, yeah. How's that? Is that better? All right. This mill's capable of anything that an industrial mill would be capable of. It can cut metal, it can cut steel, platinum, high-end stuff. We're only plastic today because it's easier and it's faster. But it allows makers to make real products. Rather than 3D printing is fantastic for prototyping, and sometimes you can do things with it, but then eventually comes to a point where you need the rigidity of a metal or materials that you just can't get out of a 3D printer unless you're spending $1 million.
Yep,
which is cool too. But
yeah. Well, the other important thing is, and you may have mentioned and I didn't catch it, speed. Now, a lot of people don't realize additive is still very slow. CNCs are incredibly fast.
Yeah, exactly.
And I found this out through working with the SLA versus a CNC seem to be more accurate and faster. So right. I don't see it going away anytime soon.
Yeah, exactly. I mean, and that thing is, I mean, we've got aluminum parts. It takes 20 minutes to mill out an aluminum part. We're talking, I mean, numerous features, threading and everything. Numerous features and all kinds of threading and stuff. And so that's part of the advantage of this machine. And the fact that, I mean, you get it and it's it shows up in a crate. It's user install. So people learn as they use the machine, as they build it. And then the fact that it uses regular power. So, I mean, it's a regular outlet. You can plug this in your garage. It's a 110. We have a larger mill that's 220, but even that's pretty standard.
Yeah, hook it in your dryer.
Yeah, exactly. We try to make it as accessible as possible. And you know, one of those things that we hear from a lot of beginners is ease of use. People come into it and they understand it, and it's pretty quick. If you understand the beginnings of CAD and CAM, you can very quickly get on a machine like this. So and the machine can be put together with no special tools. I mean,
so let's say from a design standpoint, what's the difference between that and additive?
Between the CNC and a mill and additive?
From a
design, sure. Well, that's the thing is, and like I said before, rigidity is huge. But a big part of it too is like this ABS plastic that we're milling. I mean, that's essentially the stuff that's coming out of a 3D printer. But what happens is, put something through a 3D printer, you're melting it, and that can dilute the
size.
Right. And so with this, I mean, you come with solid plastic.
and you mill it out. So our pieces, if they were 3D printed on a machine, the exact same piece, it wouldn't be as strong on a 3D printer because you're essentially, I mean, it's rudimentary, but you're super gluing layers together.
Yep, exactly.
Right, and so this, I mean, this, you're never breaking it down.
Okay, well, the other thing, maybe I didn't approach the question well enough. Obviously, since you're doing subtractive, from the design perspective, the CAD software, how does your mind have to relate to that? For instance, in my case, I've never done any CNC, but I've done a lot of additive.
Oh, sure.
So what do I need to learn?
Right, no, and definitely, and really, that's the big step in between. You know, with 3D printing, you have CAD, I mean 3D models. You do the same thing here.
Mm-hmm.
The only difference is you have to have CAM, which is computer-aided machining. But essentially, that teaches the machine the right way to go. So you have different tools, they are different lengths, they have to be spun at different speeds, all that sort of thing. And then it always changes depending on the material that you have on the mill. So all of that's done in CAM. And then it outputs the same 3D printer might output in G-code.
Server code.
And then it reads it just like a 3D printer would. But the difference is that CAM software.
Okay, so it's an additional piece. So if you're using CAD to find something, it'll do CAM as well.
Right,
And
exactly.
I heard Autodesk Fusion 360 does CAM as well.
That's exactly. And actually, we just started a partnership with Autodesk.
Oh, excellent.
So yeah, with every one of our machines, the Autodesk Fusion 360, you'll get a free year with the package.
Okay, well, I do Fusion 360, so I'm already licensed with it. All right, so what's this going to set me back?
Well, the machine as it sits right now, this has all the bells and whistles. It's got an automatic tool changer, the enclosure, things like that. This sits about 17,000.
Oh, okay.
This start base at about 7, and everything that we sell is modular, so you can buy the base and build up, and a la carte. So you don't have to buy any special packages or anything like that. You just build as you want to go.
So what? You mentioned a la carte. What's the build size? Speaking from an additive perspective.
The envelope?
Yes.
Yeah. So the travel on the machine, it's about 14 inches, X, 7.5 on Y, and 13.25 on Z.
Okay, that's really good.
Yeah.
So if you wanted to keep this in mind to the audience out there, if you're looking at a commercial printer like a Fortis, which is $30,000 to $50,000 up, you're getting something that provides, in some cases, better accuracy, more durability, even though it's attractive, for about 1/3 the cost.
Right. Yeah, and that's the thing too. Is I mean, the next step in the machining line. I mean, you're talking about a mill, $50,000 at least, and it's not going to have dedicated power. It's going to have to sit in a warehouse.
Mm-hmm.
This you can put in your garage. You can put it in your basement. You need dedicated power, and it operates just as well. The only difference between the major mill and our machine is that because the machine is smaller, it's got slower speeds. So milling heavier metals take a little bit longer. But otherwise, I mean, it's makers. They don't need it to be a production machine. We do have customers that use it as a production machine.
I could see why.
But that's why we're here, is to show it up to people who really use it.
I've been working with additive for 2 years in design, 3D design for 20 years, but I've always needed to have a CNC machine. So maybe I can afford one now.
We
So
like
Chris,
to think.
yeah, Chris, thank you. You got a card or something?
I do,
Okay.
absolutely.
Sure, I'll take that. Excellent. Would you like one as well?
Yes, absolutely. Yep.
So as you can go out to Google Plus, or I think you can actually go out to my YouTube channel and watch it live right now.
Oh, fantastic. This is like a short delay.
Well, there's probably a little bit, but when you tune in, since I'm already moving on, it'll be like it's there.
Yeah, rock and roll.
Okay, see you later. Thank you, Chris. So that was Tormac, and with their personal CNC, as you realize, it's very inexpensive. So we have, what do we got here? Metal, plastic, router, and laser. Hi. So what do we have here?
We're introducing a new 3D printer that's both in plastic and metal.
Wow, okay. So how can you print in metal?
Well, we have a proprietary alloy, a zinc alloy that we use. You can see it right here.
So that's a low temperature alloy,
Yes.
right? Okay. Okay, very cool. being low temperature, it's still much hotter than standard plastic.
Yes, it is.
So what's the temperature, or is that proprietary?
Approximately 650 degrees.
Okay. So you got full, wow, you may if I take a closer look at? Wow. So all metal extruders and hot ends, correct? All metal hot ends and extruders?
Yes.
Okay.
And it also, we can get modules for both a router and a laser.
Oh,
A laser
okay.
etcher.
Okay. So if I mind, how much does this cost?
For 2 modules, it'll be $19.95.
Oh, very reasonable.
Then each additional module is another $200.
Okay. So do you sell this entire printer here?
This as is would go for $19.95.
Okay. So it looks like it's well constructed. Are these steel or aluminum? The rails here, are they steel or aluminum?
Still
Steel.
very sturdy. If you,
Yes, I noticed that. Very nice. And so I noticed there isn't a heated bed.
but that will be an option.
Okay.
And not only will we be offering a heated bed, but also a 5-axis base.
Oh, really? So you can CNC.
So you could conceivably create a 3-dimensional circuit board.
Oh, pretty interesting. Very interesting. Okay. So it looks like it's got a very, very large bed. What's the size, volume?
14 by 14 by 24.
Wow. That's impressive. Very impressive. You got a business card?
Yes.
I'd like to have you, like to email you and have you on in an interview.
Oh, that'd be great.
Yeah, this is exciting. Really great price.
That's my business partner. He went out to use the bathroom.
Okay.
He's the one I really want you to talk with.
Okay, well, I'm up at time, but I will email him. Just let him tell your name again was?
John, I'm John.
Okay. Well, I'll let him know. I'll email both of you.
Okay, great.
And then, yeah, we'll get you on. Maybe
That'd be
for.
perfect.
Yeah, I'd love to know more about this. This seems well made.
If you could be here back in about 5 minutes.
Okay.
If you want to stop by.
All right. If I come back around, I'll see you.
Okay, great.
Thank you. Okay, so let's kind of move right on. So as you noticed, well, if you watched Sunny the Meerkat yesterday, we probably had 10 times the capacity. There are people coming out of everywhere. I'm glad that I took the shuttle today because yesterday it was maddening trying to find a parking space. I literally had to drive about a mile away from it, so it was a long walk. Can't say that I am energetic today, so I apologize if my enthusiasm has waned. But, well, as you can see, we're just full of stuff out here. I have footage from some of the booths from yesterday, so I won't go back over it. So we'll walk down. Let's go over here and see if we can get an opportunity to talk.
This is a 1/3 scale.
Hi, you mind talking with me a little bit? I'm from All Things 3D. My cable's kind of down here.
But there's no reason
Thank you. Okay, so hi, who are you?
So I'm Skylar, and that's Carlo.
Hi.
And we're with Lock and Bio.
Okay. Interesting background there. So what do you do?
We do 3D printed for biology, equipment for biology.
Oh, okay.
An example is a 3D printed incubator. This is a scale 1/3 version that you use for an incubator with a cell. You put your cells on that, and you control the heating of it with the Raspberry Pi.
Wow. Okay.
Like this guy, a little microcomputer.
Okay.
We plug in all kinds of heating elements, cameras, temperature sensors to monitor this device. All of that data, the Raspberry Pi then sends to the cloud. So we provide the services of logging and analysis, predictive failure for all of that, this kind of stuff. The design for this is open. It's available for to get and download. And if you use the right material, you can even print this out in a version that's safe for food at a high temperature. So this is, at the full size, is the size of that paper over there. This is a 1/3 size. The size of a easy bake oven or a Foreman grill. Right? So we see clearage between 8th, 9th, and 10th graders using these devices in home ec, and then using the same interface, same device in bio class a year or two later, and then using the same device in college too. Now, I would buy a 3D printed grill because that's cool in and of itself, but then put it in the dishwasher because it's safe for dishwasher, and my kid from college come home and do an experiment in his bio class in college on the main thing, I think that is a win.
Pretty neat. So what kind of customers do you work with?
We have a couple of pilots right now. We'd like to get it in the hands of students in schools as much as we can. We have some corp to corp, I think, that we can do, like this B2B stuff, scale. This thing, consumers aren't really going to be interested in the cloud offline service. Although monitoring my grill from my smartphone, that would be awesome.
Yeah.
But biology for incubators, I think that most people in research and scientists are going to hack on it themselves. But a corporation that's doing a production line, 3D print out a larger version of this, for them, they're going to want to be able to know when the hardware is going to fail. They're going to want predictive failure. Our temperature is sensitive enough, we can tell when the room to the door is open, or the door to the room is open. So we can give them all of that, the cloud offering, notify them by cell phone when something changes.
Very, very neat. I have to figure use for it. So is there any reason you picked the pyramid? Is that just a normal shape?
So that shape in particular, the pyramid we picked, because it's a self-supporting structure for a 3D printed FDM style printer, MakerBot, but a bigger version. We didn't want to have any support material. That kind is only because it supports itself as you build it. We fully expect that the community, because it's free and open to download and modify, will come up with a better design. We'd love to actually use some generative algorithms to come up with whatever the most optimal design is for space. So we think that that's probably a good application. But we're curious to see what people come up with. However they want to build platforms and bolt them together, come up with some other design than that. That's only the constraints of the printer we used.
Pretty neat. Well, thank you very much.
Thank you.
Hi. You want to give me a little bit of an overview of Shapeways? I'm actually... Okay. Hi, how are you?
Good.
I'm from All Things 3D.
Okay.
I actually know Charlie. I was the moderator at a panel at South by Southwest,
Okay, very
and
cool.
he was on it. So I have a little bit of experience, plus I have things made by you guys. So one of the things that you guys have done something new, because I think a lot of people already know who you are, is that you're making, or you have new materials now. Is that correct? And so can you kind of talk about that, plus any other type of services that you've added in the last few months?
Yeah, absolutely. So we have over. Oh.
Lighting isn't that good.
Okay. We actually have over 50 materials now. So that includes all of our plastics. We have full color stone. We're piloting porcelain right now, actually, where we're printing the molds porcelain. And we've got a bunch of different metals as well. So we recently introduced our precious plated metals. So they're a little bit more affordable than if you're buying something in gold or silver. And so then overall, we got about 50 altogether with all those different finishes included.
Wow, really neat. You know, what's funny is that I've taken your sandstone and I used an epoxy finish, and I made my own little out of colors. So I want to take that back as a tip to your scientist.
Yeah.
So it's pretty neat. I noticed you've got some quadcopters back there.
Yeah.
What's the reason for them?
So we actually recently partnered with DJI, and we're doing a contest now with our community. So we're asking designers to design an accessory for DJI drone. We actually have Adam Savage of Mythbuster will be judging the contest.
Oh, really?
Yeah, and so he'll pick the winner, and the winner will get a DJI Phantom 3, as well as $1,000 in Shapeways printing credit.
Wow.
Yeah.
So is he actually coming here?
He's actually not here. We wish he could. He's in the area, but he's a fan and
I know he
fun
is.
things.
He talks about it all the time on his own show. Oh, really cool. Okay, well, thank you very much.
Absolutely. Thanks for stopping by.
Thank you. So let's go over here to the Up Plus 2 and the Up Mini. Haven't really talked to them, but they are one of our popular printers because of their reliability and their accuracy. In fact, the Up Plus 2, if I can get in here. Man. Okay. Hi.
Got enough gear?
Huh?
Got enough gear?
No. Hi.
Wow.
You wanna?
Oh,
yeah, please. Oh, sure. Hi. So I'm a fan of your printer. I don't have one personally, but I know that this thing here is a lot of people that love it. So can you kind of give me an overview of your printers? Obviously, you got some new ones.
Yep.
Maybe we can start with the Mini and then move up to the the bed butt one there.
Sure.
So go ahead.
So we represent the Up brand of 3D printers made by. So our original design was a classic design plus, and we've been working on that for 4 or 5 years, and we think it's perfected. So what we've done is we've tried to make it a little less expensive, and we've created the Mini, which builds the same resolution, high resolution parts as the Up Plus 2. Now it's $599.
Wow.
And we're printing a part there now. Yeah, $599. Now, people seem to like the enclosure on the Up Mini, so we've decided to incorporate it into our newest machine, the Up Box.
Oh.
The Up Box has all the features of the Plus and the Mini, plus a few more, like auto calibration, a HEPA filter, fully heated chamber and build bed. And the build area is gigantic. It's 8 by 10 by 8. So that's our Up Box. It's available for shipping in about 2 weeks.
And a drum roll, how much?
Sorry?
The drum roll plays, how much does it cost?
Oh, the roll for the filament?
No, how much does it cost?
Oh, the cost.
I'm pretending like I'm rolling a drum.
And the cost of the box is $18.99. $1,899.
A dessert roll.
Yeah, and the Up Plus 2 is $12.99, and the Mini is $5.99.
Well, I remember that they, obviously when they first came out, I think they were, $1,200? And so obviously you've kept up with things, kept the prices good, but haven't in any way lowered the quality. I'll tell you what, that unit back there is impressive.
Yeah.
Were you guys at CES?
Yes, we were.
Yeah, I must have missed you.
We had a really early prototype then.
So. Well, it looks really good, and so $1,800 for that.
Yep.
$5.99. $5.99 and
$12.99.
$12.99. Sounds good.
All right.
Glad I came by.
Thank you very
much.
Are you all internet broadcast?
I'm doing it right now. It's a Google Hangouts on air.
Oh, really?
Yeah, and we've been in it for 2.5 years. Let me give you my card, and I'd like to be on in a longer interview.
Where are all your batteries?
Around my waist.
That's awesome.
So I have a unit right here, and then when I'm running my lights, I've got a 12-volt system there, and everything else is on my back. You want to do me a favor? I got a laptop in there. Could you make sure it's pushed in there?
Fully zipped up.
Okay.
And everything's inside.
Okay. Yeah. Okay. Good. Thank you.
All right. Thank you.
Uh-huh. Okay, well, that was interesting. Wow, some really good printers there. I have been a fan of it. Somebody that I started out in 3D printing, he pretty much gave up every one of his printers except that one. Okay, looks like we've got some other unique printers over here. What do we have? Oh, Tinker the Robot. I wonder what this is. Okay, so XYZ printing. So as you're probably aware, if you watched, yes, we had talked to the people out here at XYZ. If you watched the show last day, they are one of the #1 sellers on Amazon and at Best Buy. They are really coming on strong because they have a lot of low-cost 3D printers. If you remember, we also had Simplify 3D on. They are now the slicer of choice. I think it is packaged with it now. So they have moved from providing some of the lower, I should say, unaffectionately cheaper 3D printers to some of the more inexpensive, easy to use printers. Now I've heard some rumors, and maybe if I get a chance, I'll go in there about them providing a proprietary cartridge. But maybe I'll go in and ask them personally. And if you look in there, this looks like their SLA printer, which looks a little different, maybe not, from the one that they showed at CES. If you remember, it was about $2,000 or $2,500, which is, let's see, yeah, it's actually, oh my gosh, it's lower than that. It's $1,499. So I don't know if that is the show price. But if you remember the Form 1, which is $3,000. Hey, you remember me? Hey, so yeah, go ahead. Well, we're running right now.
Okay.
Sorry about that.
Hello, welcome to XYZ's booth at MakerFaire.
And I remember you. You actually talked for me when I was at CES. So.
Great. I'm Frank Penn here, introducing XYZ's newest Da Vinci 3D printer. It's in $349.
Now, was this the same price at CES?
Yes, correct.
Okay. You know, I noticed when I was talking to myself here, the Nobel 1, didn't you have a higher price? Did it drop, or was it always $14.99?
Oh, they were always $14.99.
Oh, wow.
Yes. And the Nobel will become available in June.
Okay, well, that's really important. And obviously, the quality looks better.
Right, so the resolution is 25 micron.
Okay. Mm-hmm. So what you may not be aware of, well, we also talked to the CEO of Simplify 3D, and he told us that you have a partnership with them now as your slicer. Is that correct?
That detail perhaps is outside my department, so
okay.
I do not know, but
well, I know
definitely
that.
a possibility.
Oh, yes, it is. It's happening. It's been licensed. And for my audience out there, one of the things that detracted people from buying your printer is not having a real good slicer. Well, you now have a solution for that because Simplify 3D, in my opinion, is one of the better ones out there. You've got a low-cost printer with an excellent slicer. And plus, I don't know if you saw the review that just came out. You're one of the top printers being sold on Amazon.
Right, definitely. XYZ Printing is it's currently the #1 selling 3D printer on Amazon. Also #2 market share in the U.S. too.
Yep, and they also did a study on Best Buy. You're up in the top 3, I believe. Right. And what else? Walmart. Do you sell these at Walmart too?
Not at Walmart,
yeah,
but
so
mainly on Best Buy, Amazon, Micro Center, and New.
Okay. Yeah. Well, like I said, I've got to get myself. You know, if there's a possibility of getting a demo unit, maybe the SLA, is that I'd like to review it. So whoever I can talk to about doing that.
For the reviewing the Nobel?
Yes.
Yeah, definitely.
Okay.
You can definitely speak with me to.
Okay. Okay, can I get your business card again? I may have lost it, so I've been using your standard contact form, and nobody ever contacts me. Okay, I think we did this the last time. How about just putting your email address on the back of it? Okay. It is a panoramic camera, so I'm getting a full 360. Yeah, I'm still recording. And then I'm live casting through Google Hangouts on Air, just Windows tablet, and then I'm archiving with an HD camera. Yes. Over where? Oh, you have a stand? Oh, I sure will. Let me finish up there. Okay, that'll be cool. Uh-huh. Well, you're on the internet. You're on YouTube. That's even better. Excellent, thank you. All right, I'll email. My name is Mike. Actually, let me give you my card again. Yeah, we've been doing this for a year and a half, actually almost year and 3/4 now. Okay, that's Chris Kokak, my co-host, but the email goes to the same people. So yeah, I will contact you. Yeah, I would really like to know more about it and possibly give a good review on it. Sounds good. Thank you. I hope that works out. You know, as I've said before, the Nobel is curiously very similar to the Form 1, so I wonder if it actually works just as well. So we're in the Build Tech booth, and it's funny to be able to apply a face to it. So and I have promoted their product, and they look busy right now. So on my way back, I'll cover them. Hey, look who it is over here. It's John. Hello, John.
Hey, how's it going, guys?
As we speak,
we live again?
We're live.
Awesome.
So, hi, John. What are you doing?
Just hanging out at MakerFaire Bay Area.
Yeah, another long trip for you guys, huh?
Yeah, this time drive. We actually flew out.
Oh,
instead.
that's
So
good.
First time we didn't make that long 5-day drive.
What we got here is the Mad Max. No.
Yep, we got Rostock Max and Orion up here on the table.
Right.
Some print samples and
Where's your Mini?
The Mini's not quite ready yet. We're about 6 weeks from having
6 weeks?
the Eris.
Okay. And the price?
$5.99.
$5.99. I look forward to that, as we talked about before. I have, as I told you, an interesting idea for it, so keep me up on it. So how was your Indiana fest up there?
Yes,
It was
Midwest
crazy, huh?
Rep Fest. We had a little problem with the radio broadcast, we'll call it.
A little bit.
We're not known for having great Wi-Fi. The festival, we ended up with about 1,300 people, I think,
Wow,
altogether
that's good.
throughout the weekend. So we had a really good turnout. Lots of people came. It was really neat to meet up with Sanjay and Josh from E3D.
Mm-hmm.
Maker Juice guys. Boy, there's a dozen people.
I know.
Can't remember them all off the top of my head.
Well, I
right
took
now.
some of your footage where you went around first-person view and showed it on the show. So yeah, it looked like it was exciting.
It was a blast, and we're looking forward to next year for the
Well,
4th
maybe,
annual.
Maybe not.
Yeah, oh, it'll be somewhere. Somewhere hard to get to again.
In the middle of the cornfield.
Yep.
Well, hopefully, maybe this year, now that I have enough time to realize it, I'll make it out myself.
Yeah.
Then we won't have to worry about any radios.
Yeah, we'll have to
I'll put a
record
big
it and
antenna on my back.
upload it that way. It might work out better.
Okay, well, thank you, John.
You bet. See you guys.
Bye. So that was John of CNC. We've had him on several times. And wow, I am a little surprised at the number of people. Well, let's take a look here. Bellman, not familiar with them. Yeah, it's interesting. Some of these shows, especially the maker fairs, seem to bring out quite a few of the, what do you want to call it? Not necessarily the lower end, but maybe the lower marketed versions of 3D printers. They're busy. I'll come back later, but I'll have to look into them. One of the things that I have noticed in the last few years is the quality of some of the not only lower end, but the lower production or smaller companies 3D printers. So here we are at Form Labs. So let's see. Well, we've had them on before. If you remember correctly, they have the Form 1 Plus. Yeah. So hi, you guys want to talk a little bit? Okay. Well, how about I go down further and come on back? No, they didn't seem too friendly. Okay. So there he is. So we have this young gentleman here. Wanted to get an interview.
So, hi, my name's Zach.
Hi, Zach.
And so, as you can see here, my project is I am CEO.
You're CEO of what?
I'm CEO of Minority Name Tags, and I'm helping kids and inspiring them to become CEOs.
Wow.
So I 3D print items like this.
Uh-huh. What
3D
is it?
print these items, and I sell them. So for this, I wrote a book. Called I Am CEO.
Uh-huh.
And basically, it's got my adventures becoming a CEO, and so it's $15, but you can pre-order it on my website. Pre-order it on my website right here on imco.club. So here's my card.
Wow.
So imco.club. So imco.club, and you can pre-order my book for $15. If you're here at MakerFaire, you can get it for $10. So.
$10, huh? Wow.
Yeah.
Pretty cool. So make sure anybody who's watching this later on to come on by. And what's your name again?
Zachary.
Zachary, that's right. So pretty neat here. So who's this guy here? Is this your assistant?
Yeah, that's my dad, my secretary.
That's what I thought. Pretty cool. Well, obviously your secretary is on the right path. All right. So very cool. So yeah, I'll look you up and mention you on my show this next Friday, okay?
Thank you.
All right. Thank you. Hi. I am.
I think I have something that would interest you over there.
Okay.
Do you want to swing by? We're called Imaginary Space.
Where you at?
Whenever you come by,
okay.
It'll be right over there near the entrance on the far side. It's called Imaginary Space. So
okay. I will head on. Yes, please. Okay. Well, you guys are a long way. Hi, want to talk a little bit?
I don't know.
So this is a maker school in Budapest.
Yes.
Correct?
We came here from Europe to introduce our maker school. We are on the preparing phase, and we will open in 2018. And we came here to make a direct contact with Maker Media to understand and see everything what media do it here. That's why we are here.
What do you think so far? Crazy, huh?
Actually, it's a very wide range what you can see about makers and the way of thinking.
Now, if I remember correctly, isn't there a company in Hungary that's a 3D printer?
Pardon me?
Do you not have a company in Hungary that makes a 3D printer?
3D printer, there are, I think, 2 companies.
Yeah, I think I interviewed one of them. It's actually a pretty neat one. I can't remember the name of the company now, so that's why I came over here. So,
Yeah.
it's funny. All around the world, we got makers, print manufacturers. I've been doing this for about a year and a quarter now, and I interview a lot of different manufacturers. Yeah, it's a small world, as they say.
Yes.
Well, I hope you enjoy San Francisco and get the most out of it. How long are you here?
We will go to the East Coast tomorrow.
Okay.
And we will check some maker spaces there. And next week we will go back to Europe.
Great. Well, enjoy your trip and whatever else they say.
Thank you very much.
Thank you. Okay, well, that's kind of interesting. I wish I remember the name of the company, but I didn't. So we're going to swing back through here. It appears this is a lot of the smaller makers in their representation. Okay. So what is this? Go Vikings. I saw this yesterday.
This is Irvington High School's robotics class. So my students have projects that they work on all through the year, and separate from the curriculum that I teach, each kid gets to pick a project.
Wow.
And so we're showing them off at MakerFaire because I teach the best kids ever.
So is this a local high school?
It's in Fremont. Yeah.
Fremont, okay.
Public high school. We're the only robotics class in our school district. So Alan made a Tesla coil.
That's cool. I made one too at your age.
That's awesome. So we have earrings that kids have designed. Some of those on there are little maker earrings that we didn't design. We got them here, but then we made them into earrings.
Cool.
Daft Punk helmet.
Yep.
That's a quadcopter there in the frame so that it doesn't hurt people. Another one of my students, Andrew, designed that.
Wow.
He built the frame himself. We 3D printed the parts for the quadcopter in our classroom on our 3D printer.
Okay. What type of 3D printer do you have?
I have a Robo 3D and a MakerBot replicator too.
Okay, I have a replicator too as well. I modified mine, put a heated bed on it.
Nice.
Yeah.
Steven is back here playing with the laser cutter. He just made these little MakerFaire earrings.
Cool.
So he just printed another one. I just cut out another one right now. And
you seem to have a lot of passion for this. Other than being a teacher, which is not a small feat, because I've done it for several years in the military.
Yes.
But what is your background?
My degree's in math.
Okay.
And I taught math for 8 years, and then got tired of people, mostly students, saying, we don't really know why this is useful and why we are supposed to learn this.
That's an excellent
So started doing a little bit more engineering stuff. Asked the principal at my school 2 years ago if I could teach a robotics class as part of the curriculum as an elective, and he said, totally, yeah, for us. So I put some curriculum together, and here we are 2.5 years later, and my class has been going for 2 years, and my kids are amazing.
Wow. No, this is fantastic, and I know I do monthly, what do I call them, roundtable discussions.
Yeah.
And we did it on 3D in education. So we had the CEO of Ultimaker, a couple from Canada. So we got a different perspective of how the educational systems are inviting 3D and this type of stuff in, and it's much different in Europe. They seem to embrace it better, as well as in Canada. And we're finding in the United States, it's more of a personal, like people like yourself that are bringing it in. In fact, in my town, I tried to use it into the library system, and they wouldn't take it because they didn't have anybody to operate it. So
it does take a certain amount of maintenance and work. And I mean, my MakerBot, I've taken it apart and put it back together 4 times because different parts have failed, and you have to be able to fix it. But it's so worth it because the kids just love the 3D printing. We scanned, this one's me, so I don't know if you can tell. We scanned the whole class, and we're printing the whole class. So we'll have the only 3D printed class photo on campus.
Oh, that would be cool. So what type of scanner are you working with?
This was done with a Kinect. Xbox Connect?
Well, I design and develop software for the occipital structure, and I make a lens system for it to give it about the same quality as an RTEC scanner.
Cool.
So not only do I do that, but so I'm releasing that app probably end of May, early June.
I am going to get a 3D scanner, like a good one. The Kinect belonged to a student. He brought it in. So
Well,
I need to get a good scanner for my room next year.
Okay, look for a structure sensor by Occipital, $375, and then go to Slow 3D Creators, which is my site.
Yeah.
I make a lot of accessories for it. Cases,
Okay.
It's iOS, plus you can use it with PC software and Mac software so that you can use the power of the GPU in those machines. You do some really nice scanning. So go out to my site. You can see some of the results.
Okay, all things 3D.
Things 3D.
Awesome.
Okay, thank you very much.
Thank you.
Glad to see people like yourself doing this. Hi. Well, that is really exciting to see somebody that enthusiastic, kind of talking about 3D printing and a lot of things like that. Well, Lozbot, like usual, has a huge crowd. I don't know if I'll be able to get in there. Yeah. Yeah, it's actually streaming live as well. That's okay. No problem. We'll sneak in right here. Well, as you know, my co-host Chris is very enthusiastic about Lozbot. In fact, he has the Taz 4 and decided to get a Taz Mini. So he's been converted almost like a religion with many of these printers. And he obviously has taken the pill for Lozbot. So I'm not going to interrupt them. We know a lot of them. They make a great printer. Surprised the number of 3D printers. I think we have more this year than last year. I know that all the Maker is here. Obviously, MakerBot is here. Yeah, there's just a lot of stuff going on. This thing just keeps growing. I'm not even out of this first tent. So what time do we have? We got 3:43. So we'll see how long I can continue to manage this, but we'll just keep moving. Well, let's see if we can sneak in here. Hi. Can we kind of talk to your printers?
The CEO over here.
Which one's Brooke? Okay, well, he's talking to somebody, so until then, you can talk about it.
I don't. I got like a.
You, huh?
I got like a cold. We have two booths. Hey, Brooke.
That's okay. Obviously, is there nobody else can talk in the booth? Okay, well, thanks. Well, you got 5 people hanging out in the booth, and none of them want to talk. It's kind of sad. Obviously, the CEO, I don't want to interrupt him from what he was doing, but so we'll just keep kind of moving on. Wow. Hi. You know, that's what everybody says, but you're doing. Okay. So you don't want to talk? Okay. Hmm? Who would? Okay. Excuse me.
Yes.
Well, right now. Yes. So what do you do?
Hey, Andy. Right up your house. Come on over here.
Everything. This is the king of all
Okay.
3D.
Who is the king?
And Tyler.
Hi, Andy.
Got
So,
that history.
okay. So what do we got here?
Well, there's a number of printers here. You have the Idea printer. You have
Go ahead and bring it up. There
you
you go.
have the Affinia printers.
Okay.
You have the Up printers. So you have a whole spectrum of printers here that represent some of them are cutting edge machines that are appearing on the market now.
So are you part of this booth?
Yes.
Yeah, he's
Okay.
my biggest advisor. So,
Okay.
part of Dave Martinez Ventures.
So what do you actually do as far as not only printing, but
I do 3D design and printing. I've been doing 3D design and printing for the past 15 years.
Okay.
Worked with a company called Made in Space who actually put the printer on the ISS.
When I was at Rio 2015, I had an opportunity to talk to you guys there. Great.
I use 3D printing routinely. I 3D printed
ahead.
components. I've 3D printed components that have gone into space.
Oh.
Use 3D printing to evaluate ideas for use in space too.
Well, it sounds impressive, and I probably should know who you are, and I don't, so I'll have to go look you up. So essentially, you've got some history. It's interesting. Professor Cal Pauly actually did some studies with the initial, maybe about 15, 20 years ago, with 3D printers in space. So obviously, you've taken that even further. So anything else in the future? I know that, what is it, the international group, NSA, is going to, is going to be putting up something that's PLA oriented.
I mean, you know, really 3D printing is still an untapped area. The chemistries, the designs, everything is just in its infancy. We're looking at hand-cranked Model Ts still. You know, the ideas that you can print living tissue, that you can print foodstuffs, that you can print metals, you know, and no one has really cornered a standard on any of it. I mean, there are some early things right now, but they're changing as we talk.
That's true.
Yeah, some of the interesting things we're talking about working with Andy is that we just started talking about to print prosthetics and make prosthetics a little more engineering and a little more affordable and make the use case scenarios for people with those injuries and those prosthetics to be able to live better, maybe go in the water more often and print some prosthetics that they do all that with. That makes their life easier so they're not dealing with all the hardware. How do I know that? I have one. So working with Andy, we've talked about it, and we're actually going to start using this machine right over here, the Idea printer, F100, which I call Bigfoot of printers. It just came to me when I looked at it. It's pretty awesome. You see the size of the hand and the print bed there. And we're going to start there with that, and who knows where it's going to take us. And we hope that we can help a lot of people that have ill-fitting prosthetics that will be able to make their lives easier. That's one of the things that I like to do for people. If we can change one person's life, maybe we can change the world's life.
So you're familiar with the Enable movement? The Enable? Enable?
Oh, yeah, I think that's something down the line we're going to look at. First, we got to get started. We have the means and the tools now to do it. And with Andy's help, I don't think there's anything he can't do. So I'm just that guy that talks in the mic and has that great idea and vision. He eats it out and has a better vision. So together, you know, maybe you'll go to space with the prosthetic.
Yeah, also look into Unique. They're out of Spain. They also do prosthetics, and they try to glamorize them. I just saw, I was part of a 3 presenter out at Stanford, and he was one of the group out there.
Sorry, I couldn't hear you.
Yeah, I know, it's kind of hard in here. I was at Stanford the other day, on Thursday, and there were 2 other presenters by myself. One who's doing bioprinting. In fact, they're over in the Stanford booth, and it's a very compact unit, so you were talking about bioprinting. And then the other one is doing prosthetics, but customizing them and using art to make them more fashionable from something called Unique. So those are 2 things that I know are coming up. I've been doing this podcast for about a year and a half now, so I've had an opportunity to talk to a lot of people. And one of the reasons I'm here is to talk to some more people. Do you have a business card? And I'll give you my business card. Oh, great. Sure. Huh? Yes, you did. Yeah.
The cost of the machine, you know, the cost of the cost. So that's
No, I know. And that's one of the things he pointed out. He's able to make something that normally costs $20,000+ for $5,000 to $8,000. I mean, out of carbon fiber, that they're using some obviously higher end printers. But what you can do with these things now, the Enable program and what they're doing with children, obviously either have deformed or amputees, then they can grow with them, make new ones because it's so, yeah, it's really exciting and look forward to. I'll email you and maybe we can have you on as an interview as you progress with your ideas. Thank you very much. Excuse me. So I talked to them yesterday. I've got some offline footage. That's Microsoft 3D printing. But, you know, I haven't even gotten out of this tent yet. I'm going to go talk to one more person. I also talked to Dremel. They have actually doing very well. They've become very popular. I think their printer now is $8.99 or $9.99. As you know, it can be bought at Home Depot, but it also can be. I think they're going with some other people. So, brief interview. Upload it later on. Okay.
Well, yeah, we can make it.
Excuse me.
Everyone's got COVID.
Hi, I had somebody hunt me down to your booth. So yeah, I'm from All Things 3D. So if you'd like to kind of give me a okay, if you wouldn't mind taking this, hold it about 2 inches.
Like, you hold it, I can show a demo.
Okay.
All right, so we're Imaginary Spaces. What we allow you to do is you can create any living space that you can imagine and then 3D print them. So for example, let's say you want to build your dream home or any bedroom or room in your house. What you can do is you can really easily edit these rooms. So you can maybe add a section here, add a section over there, add some more stuff here. You can edit it really quickly and on the fly. You can even add windows, add doors, all kinds of cool stuff really easily. But even once with that, it's still hard to get a real idea of what it would feel like to live inside. So what we allow you to do is to give you a first-person mode that you can then walk around in, explore, so that you get a much better idea of what it is. And you can actually edit it on the fly as you go. So you might notice this wall needs a window. I might add a window there. This could use a window as well. I could use it there. And then once you've got something you like, for example, within 10-15 minutes, you could design this penthouse apartment. You can 3D print it. So to give you an example, one of our users made this maze here. And once you 3D print it, it gives something like this. So wow. Right from the software, you can really easily 3D print things.
So what does it export as?
So it exports STL files.
Okay.
So if you have the 3D printer, we give you all the STL files for free. Or if you don't have a 3D printer, we handle everything for you through Shapeways, and you receive a 3D print in the mail for a small fee. Otherwise, if you play Minecraft, it all converts to Minecraft blocks, so we can send it to you on a Minecraft file as well.
Wow. So are you a developer?
I'm not a developer, but Simon and Benoit are the two developers.
I'm a developer. I'm creating a thing called the occipital structure sensor. Plus, I'm coming up with a product called NeoVR, which allows you to use the sensor so that it knows your environment. So maybe we should talk. What are you using? SceneKit on this? What's the engine that you're working with?
We're using the game engine.
Okay. Okay, so you are using Unity.
generated. So yeah, we're using a game engine.
Okay.
We're using the Unity game engine, so that gives us the gameplay.
A little bit closer.
We're using use the gameplay,
Okay.
and all the geometry. We have a geometry engine, so all the geometry generates on the fly.
Oh, okay.
And what we like to do is we like to get some 3D cameras that we can actually scan real environments, bring them into our software so that you can quickly scan a place and edit it in almost real time.
We'll talk to a hospital, the structure sensor.
Yes, I know. Yes.
Yeah, they actually most of the stuff is done in iOS, which I'm assuming that's what you have here is an iOS app.
Yeah, we have both an iOS who runs on the iPad, runs on the iPhone.
Okay.
It also runs on Mac as well.
Oh, okay. So you're an Apple group then.
Yeah, we use the Windows. So we're currently working on an Android board as well.
You've got a broad group then.
Yeah.
Well, they have developed their sensor for the iOS platform.
Right.
And it's enhanced using, I think they're using Metal now as well. So it's both GPU utilized. It uses the OpenGL functionality. Plus, you're familiar with the PrimeSense Connect. So it uses a newer version of the PrimeSense OpenNI in order to bring the stream in.
Right.
And it can capture rooms. But more importantly, like I said, we can reverse it so that you can be in that room. So let's say if you're in a standard bare room, it knows where your walls are. It can map them to the VR.
Yeah.
So I have a prototype headset that I'll be showing off tomorrow.
Oh, we're very excited to see that.
Yeah, so we should talk more. I'll give you
Yes,
my
please.
card, give me yours. And maybe I can have you on.
No, that sounds like a very good.
So I'll give you my podcast card, but this would also get to my other. So I run two companies, this one as well as Slow Traders, which is my 3D print, design, and scan. And I also obviously do some development.
Okay, yeah, we're really interested in this card because we want to be able to decorate. So we want to be able to easily scan things and get them into a format that we can use and bring into our system.
Okay.
So that you can actually create with stuff that's in the real world as well. So think Etsy shops. They want to scan the designs and decorate in a virtual platform, but provide a way for people to do that and also order online very quickly with just a tap of the button.
Okay. Yeah, so like I said, you can either contact me and I'll give you all the information. Plus, I can put you on my beta program for my app for it. I've got a pro type version that gives you a lot more features with scan functionality, higher mesh detail. I have a lens system that allows you to get closer for more detail. So it's all built into my app that's coming out probably end of this month or probably more likely middle of June.
All right, yeah, we'll be excited to see that. Thank you.
Thank you. All right, well, that was Imaginary Spaces. That could be pretty predictive. So let's keep moving on. So I'm going to have to stop here in a moment. That's an unusual setup.
Huh?
It's an unusual setup.
Yeah. It's a Google Hangouts streaming system.
Are you broadcasting to some kind of
Yep.
big website?
Well, actually out to Google Hangouts, but my YouTube channel is where it'll eventually archive, which is All Things 3D.
What's your YouTube channel?
All Things 3D.
Okay.
Okay. Sorry for the brief. So if you've been viewing, you could have just skipped over that. Maybe I'll edit it out later on. All right. So let's continue on our way. All right. Let's take a look at this side. The barrier wrapper. So I don't know if we can see that here, but that is a hi. So what do we have here? Oh, okay. So you want to kind of talk a little bit about what you've got here? Hi. Hi, how are you?
Good. What's that?
Well, you have now broken.
What camera am I looking at?
Whichever one. Actually, this is our
Okay.
streaming one. So if you want to do yourself live, you can go out to All Things 3D on Google Plus. But essentially, it looks like you're 3D printing pancakes.
Exactly. Well, this is the Pancake Bot. This is the Pancake Bot. The Pancake Bot is the world's first pancake printer. And essentially what it does is allows you to take any design that you want, pop it on the computer, and redraw the pancake how you like it, press print, and then you get your pancake of your choice. Here we got a little rocket pancake from MakerCon. And we're also working on those spiral pancakes that were generated with a little algorithm that was written in Python. This is a way that kids can learn about technology and get inspired by making pancakes and learn about food and how food machines work. So that's Pancake Bot for you.
Cool. So what does something like this cost?
The retail price is going to be $2.99, and it's going to come with a griddle, and it's going to come with an SD card with a library of images that you can use, along with the software you can download off the web. It's going to let you draw your favorite pancakes or your favorite characters yourself.
So when can I get one?
In October or early November of this year.
Okay, are you going to do a Kickstarter or you just...
We were on Kickstarter already, and
really?
we raised
Okay.
$460,000, and that was to help us with our manufacturing and licensing and everything like that, or certifications. And so now we're, bringing it to market. So.
Okay. Great. How about giving me a card or something? I'd like to have you on our regular show.
You can reach us actually at pancakebot@gmail.com.
Pancakebot. Okay.
And then see how that goes. So.
Okay. Great. Well, thank you very much.
You're welcome. Thank you.
Hi. How about giving me an overview? Obviously, the important thing here is that it prints cool. I guess no more burnt figures, huh? So it's kind of like the Doodler, except cold print, right?
Yeah, you have is CreaPop. It uses cool ink, so there are no hot part, no melting plastic, and no bad smell. And you can do whatever you want with it. What's really cool about it is that we have inks with a variety of properties. So what I can show you here is magnetic ink.
Oh.
If you hold out your hand in front of the camera, and if I bring this here, the magnet, boom, and I'm picking up all of the pieces because it's magnetic ink. What we have as well is aromatic ink. So they have different nice smells that we fuse into the paste. Let me show it. So, temperature, it will change color because of the temperature of my body.
Go ahead and take the microphone.
Yeah, squeeze it.
You have to keep the microphone somewhat close to your mouth. There you go.
I squeeze it for a little time, and it will change color.
Oh, interesting.
Thermochromatic ink. Here we have glow in the dark, if you show it.
Pretty neat.
So what we really want to do, CreaPop is really about innovation in materials as opposed to really printing. So we are working on a number of other inks, a conductive ink, body paint ink, elastic ink. And we really want to unleash users' creativity by enabling them to create whatever they want in a range of materials as well as colors. Because we think for too long, 3D printing has been stuck with just filament plastic, which is clearly limiting. And you see the pen being used here. Since there are no hot parts, my colleague Ilya is just doing it straight on his thumb.
Yeah, I saw
so
that
you can
there.
do 3D nail art with this.
Oh, interesting. So what does this cost?
So you can order it on creapop.com and you get a box which contains a pen and 3 cartridges. Each cartridge is enough for 14 meters of creation. So what is that, about 45 feet or something? So relatively long, $119 online. And the refills will be $19.99 for a set of 3 in various combinations.
You mean 1919?
And 119, so 119 for the starter pack, and then $20 for the refills, $19.99.
That sounds good. Very reasonable. And they're available now.
They're shipping very soon. We're finalizing these units that you see here. They are mass-produced units. They are not samples. They are from the production line in China. We're finalizing now the surface coating on some of the plastic parts because our ongoing reliability testing showed some wear and tear effect based on the test protocol. So we don't want that to happen. So we're improving now the surface coating, even though, I mean, I've never been able to scratch or do anything myself, but we want to have a really good product, and then we're going to ship them when we finalize that problem.
Wow, that's really neat. How about I take your card, and maybe I'd like to have you on my regular week show and talk about it a little bit.
Sure.
And I look forward to getting one of these.
Thank you very much.
Thank you.
Only challenge here is noise environment.
Oh, yeah.
To
That's,
hear your questions. I was really trying.
yeah, everybody is saying that. The problem is I can't speak too loud, otherwise I blast out my own mic. So, oh well. Well, thank you very much. Hi. We're live.
I'm not working.
Oh, okay. Are they coming back? Sure, actually, yeah, give it to them, and I'd like to have them on my weekly show. I will be, but I'm actually one of the speakers, but that won't be until the afternoon. This is my co-host card, but it goes to the same place. Okay, thanks. That's all right. So this appears to be the company that I did an interview with too long ago. So let's see if I can get in there. You remember me? I'm from All Things 3D. Yeah, we did an interview with you guys not too long. You were my guest crasher. You guys were my guest crasher. The CEO of your company?
Yes.
Yeah. Who's that?
I'm the CEO.
So did we talk together? Or did you have another representative?
When was this?
3 months ago?
It must have been Chris.
Okay, he looks familiar.
Chris, yeah.
Or you, doesn't matter.
Sure.
Okay, here you go.
Let's do it.
So at the time, you had actually launched on Kickstarter, and we kind of went through your process and how it was really cool and how you'd be able to use it with multiple printers.
Yeah.
So why don't you kind of tell us where you're at now with it, since it's been a few months.
Yeah, absolutely.
Okay, and I'll just kind of have So you can either get behind or
Sure.
Maybe not. Maybe if I get in here. Excuse me, sorry.
Chris, did you do the interview 3 months ago with All Things 3D on the phone by any chance? I don't think so. Okay.
Huh.
We are still on Kickstarter also.
Okay. Go ahead and bring it up to your mouth.
Yep.
Well, I remember this is the box, so I don't know who I talked to, but I had you on as a guest crasher. Now, did you just launch? I mean,
we launched about 3 weeks ago.
Okay. Are you from Canada?
We're from Canada.
Yeah, I talked to you guys.
Yeah?
Yeah.
It might have been Sarmad. Maybe it was, you know what? We had, it was probably Sarmad.
He had to leave for personal reasons, so it was probably him.
Okay, I think it probably was. But yeah, we went over your whole product and everything else.
Amazing.
You guys didn't even watch it, huh?
Sorry about the confusion there, yeah.
No, that's okay. Well, I'm glad I wasn't confused. I am a little older than you guys. I'm thinking, oh my God, it's going already. No, but hey, tell me a little bit more. It's been a few months now. Obviously, one of the things that I found intriguing about it is that you can pretty much take standard printers, 3D printers, and feed it with your proprietary system here that runs a multiple colored ink or color inks, filaments.
Exactly.
So you could take it from there.
Okay. So we wanted to design a technology that solved.
Go ahead and bring it close. There you go.
We wanted to design a technology that solved a lot of the problems that are currently there today with multicolored 3D printing. So we're pioneering a single nozzle technology. What that means is that colors are coming and different filaments are coming one after another through a nozzle, which leads to really high quality results. But number two, it was also really important to allow people to get their hands on this technology today. So we designed the palette, which is printer agnostic, meaning that it works with almost any 3D printer. As long as the printer uses 1.75 millimeter filament and you can source Cura or Slicer as the slicer, then they're compatible. So here's the palette right now. You can see it taking 4 different filaments, and it's combining them together, feeding a single strand into the 3D printer, timing it at the exact right time so that each color arrives at the nozzle, giving you, the color exactly where you want it without any of the dripping or calibration issues that you might be facing today.
Yeah, and obviously it's very slick. And some of the questions I had in the interview that I did with this other person was I noticed that it's somewhat discrete in colors. Are you working on blending or essentially one color at a time?
Our initial goal actually was to make a full color platform, but we had to sort of test the market, and we realized that even if we did today, it would be very difficult for people to use it because there isn't really a way to be modeling gradients and such of color. So our first step was to introduce high quality multicolor to the market, and that's what the palette is. So the palette takes in 4 discrete different filaments. You can leverage some of the incidental blending, like in this case, you can see we use blending to make a really cool effect in the card holder. But a lot of the time what we end up doing is getting rid of the transition material on the side, so when you come back to the part, you get really high quality, crisp colors, as you see in the bottom sample here.
Mm-hmm. Very cool. Well, so how soon? I mean, obviously you launched on Kickstarter. When can we see this out? When can I buy one?
So yeah, we launched on Kickstarter a few weeks ago. We have 5 days left in our campaign.
Okay.
We're overwhelmed with the reaction, the results of it. We're shipping our early bird units in December, and the next few hundred will come early January, February 2016. And then if you miss the campaign, we're going to be collecting pre-orders on our website, and we'll be shipping after the Kickstarter orders.
So when will you be collecting pre-orders? When will the pre-orders be coming?
We're likely going to launch pre-orders on our site a couple weeks after the Kickstarter campaign ends.
Okay.
But of course, we're going to focus on fulfilling Kickstarter before.
And that's the only right thing to do. Some people have not realized it, but glad to hear that. Okay, well, I'll be looking out for and the price, if you don't mind me asking.
Yeah, so it is $8.50 Canadian.
Okay.
So depending on the exchange every day, it's about $6.75 US.
Okay.
And that's, of course, the Kickstarter reduced price to sort of give back to our backers and make it as accessible as possible. After the campaign, it's closer to the $1,000 price point.
Okay. Well, I'll have to keep that. So if I pre-order during that time frame, I can get it for whatever the Canadian rate is.
Sorry?
The pre-order, the initial pricing is how much again?
So the pre-order on Kickstarter is $8.49.
Okay.
The early bird units started at $5.49.
Okay. Well, those are already gone. Probably
Pretty quickly. Yeah.
Okay. Well, great. I appreciate your time.
Yeah.
And I'll probably follow up maybe in 2 or 3 months. See where
Absolutely.
we're at. Okay.
Yeah.
Yeah. Go ahead and give me that.
I'm going to give you my cards that. So I'm Mitch.
Hi, Mitch. So you're the CEO then?
I'm the CEO,
Okay.
yes. You must have spoken to Sarma, who's our marketing.
Probably. And I'll give you my card or my co-host. And then, there you go. I'm actually Mike. That's my co-host. We do it together, and that's all I've got left. So, but the email address goes to me. So yeah, follow up, and then we'll get you back on, and then we'll see how this all is going. But yeah, it's a very interesting product. So thank you. Bye. Hi.
I'm not exhibiting here, but I'm doing affordable version of laser sintering machine.
Really? Where's it at?
So we have like this kind of prints.
So do you have a booth? You just
No, we don't have the.
Okay. Wow.
Yeah, but the thing is that we are like.
Here, go ahead and hold that up close to your mouth.
Okay.
So you're doing laser sintering.
Yeah, so we do laser sintering, quite affordable version of laser sintering. So we have some, for example, printed couch. So you cannot print it on a regular FDM because you have foots on the on the back too. We are able to make working mechanisms. So like we can have a chain, we can have like working mechanisms here. So this is this was done in one single print, and we are able to print around 100 of these kind of keychains at once. So you don't need a lot of labor work afterwards. And also we are able to print a book. So we are able to do even this kind of stuff.
So what is the name of the company?
Sinter It.
Sinter It. Actually, I covered you a couple weeks ago.
Okay. So
yeah, no, we're excited about it.
Okay.
Huh?
In Berlin, you wish. So
we're all things 3D.
Okay, so you covered us on.
I saw it. I normally cover the news on Fridays.
Okay.
So I saw it there, and I actually sent you guys a contact to get you back on the show. So give me a business card, and I'd like to do an interview with, so we can talk about it more.
Okay, I'll just give you my business card.
So actually, the quality is pretty good.
Yeah.
Obviously, you have those same. I said, those look familiar. You have those up on your website, or one of the people
that's online, some of that. But the thing is that like try to touch it and feel it because it's quite different story when you like that's.
And there's my card.
Okay, thank you.
Pretty neat.
Yeah, so we are really unique comparing to others.
So my question I posed, and since I didn't get a chance, was SLS printing, for the most part, most of the patents expired. So one of the reasons that you're moving in this direction?
So we are not stopping what's not patented, what was patented, but we have our own way of 3D printing. So we are basing on laser sintering, but Like we are basing on this.
You keep moving closer.
Okay.
No, that's good.
Right, okay.
All right. So you're baiting on laser, but what makes
So the thing is that let's compete what's in patent that's expired that we invented. And that's why we're able to make it affordable and like with really good quality. And so, for example, this book, because we didn't found anyone up till now to copy that, so we are waiting.
So on that note, did you have a price when it was announced, or
So we about exact pricing. We plan to go for pre-orders for around 5,000, and later on resell price resellers will be like around 7,500. But still, it's not solid price yet.
Wow, well that's really nice. And, I think that's what caught my attention. So like I said, I'll follow up on this. We'll get you on the show either as an interview, 30 minutes, or have you as a guest crashers on Friday to talk more about it. But we're kind of excited about it. Our co-host and I do a lot of 3D printing. We follow a lot of different things, and you print out there. So where are you from?
We're from Poland, from Krakow.
Okay, a couple of, that's what I made the point on, there's a couple of people from Poland that are doing some really great 3D fabrication.
Yeah.
So you flew all the way out here, huh?
Yeah. So we came here. We also went to we were in Las Vegas on collision conference.
Okay.
So we like going around US and heading back to Poland tomorrow to work hard to make this possible.
Well, I look forward to it. And again, I'll email you and get you on. We use Google Hangouts on Air, which is what we're live cast right now.
Okay.
And then everybody in the world will be able to see it.
Thank you.
Thank you.
Thank you.
Uh-huh.
Thank you.
Bye.
Bye.
Okay. Yeah. So, cool. Are you at university? No, I'm not. I work in solar. Okay. Well, that's good.
Hi. You want to give me kind of a brief rundown of what we have? I'm from.
I don't, but I could go. Or
You want to? I'll give you the mic. Keep it as close as possible to your mouth.
Yep.
So essentially, this seems Structure 3D. Can you kind of tell us where? Up a little bit. There you go.
And so just give a quick pitch of what we're doing?
Yes, please.
Cool.
Go ahead.
Good to go?
Yeah, we're
Hi.
live, by the way.
Oh,
We're on
awesome. I'm Andrew Finkel, the CTO at Structured Printing. We do 3D printing and paste. So things that cannot be made into filaments now are able to be built into a 3D shape on a 3D printer. So what we do is we make a extruder that is universal. It works with a lot of different 3D printers, such as the PrinterBot, Ultimaker, a lot of the different people here in the tent today. And the idea is to complement the plastic filament printing. So right now we're printing silicone RTV, high temperature, and we're making our own customized gaskets. And this morning we were printing with Nutella, so we can do everything in. And it's been designed so it's food safe. Everything is medical grade, so you can go from silicone to Nutella, not have to worry about anything.
Oh, really nice.
Yeah.
So what? $349?
Nutella gas. Pardon me?
$349?
Yeah. So we're selling our Discovery unit this weekend for $350. It's on sale. It's available on our website, structured.io. That's structured with 3 instead of an E.
Okay, because there's another company called Citadel that I developed called Structure.io as well.
Yes, and they're doing the scanning, right?
Yep.
Yes. We were talking today. We were thinking about doing a commercial high structured and structure.
That sounds kind of fun. Yeah, I actually do all the work with them. I've designed some accessories for their product. But yeah, that's really cool.
Thank you.
So what I'd like to do, I don't know if you gave me your card already.
Yeah, I'll give you my card.
Yeah. I'd like to have back on either as my crasher or maybe an interview and talk about the process.
Yeah, I'd love that.
So I'll follow up in the next week. Pretty cool. So this is available now?
Pardon me?
Is it available now, or is
it's available on our website right now. Our lead time is about 8 weeks. We're just finishing up the final shipments for our Kickstarter that ran last summer, and we're hoping to be able to start being able to meet the orders in shorter demand later this summer.
I know how that is. Okay, well, great. Really appreciate your time.
Thank
and
you.
Look forward to talking to you more.
Great to meet you.
Nice meeting you. Thank you. So I actually interviewed them, DWS Labs at CES, and yes, they have an SLS printer. Here we can take a look at it. It's actually printing there. So one of the things is that it is a little pricey, but it's a very good quality. They have some unique software. In fact, I believe that's the same woman that I had talked to when I was at CES. So I won't bother them again, nor waste any more of your time today. So let's see where else we can head out to. Let's see, I think I'm going to get some fresh air. So one of the things here at MakerFaire is that you get a lot of unique people coming out with all kinds of interesting inventions. We have somebody here. Maybe he can give us a little bit of a rundown of his contraption here. Hi, how about speaking All Things 3D about your...
All Things what?
All Things 3D. Obviously, this is pretty 3D. What do you got here?
No, this isn't 3D printed. This is, machined with an old hand, Bridgeport.
Well, that works.
Yeah, yeah.
Pretty cool. So is it, obviously it's electric?
Electric, yep.
Yeah. And how long did it take you to make it?
Oh, geez. About 6 months thinking, and then about 3 months building. But then to get it to run and hold up, that was another 6 months.
Yeah, isn't that how that works?
Yeah. Once you get it running, you just started the project.
Well, thank you very much.
Welcome.
Okay. I am. I do a podcast called All Things 3D. I'm not familiar with it. Do you want to kind of tell me about it? Are you in there? Do you have a booth? Oh, man, I don't want to go back. Oh, how far are you from here? Let's go. Being brought back in. Okay. Okay, yeah, you look really busy. But yeah, please. Well, how about you tell me what you got there?
He's more, he talks better in the camera.
So we are in the Fab booth. Huh. Hi, I'm from All Things 3D. I've been doing a podcast on this YouTube channel for about 1.5 years. And obviously I'm at MakerFaire, and I would have went by you because you look pretty busy, but she grabbed me. So how about giving me a little bit of a rundown of what you've got here?
Okay.
Then you'll have to go and bring it as close as you can to your mouth. Go ahead.
Hi, I'm Marco from Factotum. We are a new startup working on the Factotum personal fabricator. We are based off Italy, in Milan. So what we did is a printer that is also a milling machine and a scanner all in one. And it's an open source project, so everything can be found online, and the software as well as the hardware. And allows you is to create different projects with different materials as well with different technologies. Like, for example, you can engrave PCB mills. You can do electronics. You can do the case with normal 3D printing. And you can also create mechanical parts with milling. So you can, for example, mill something out of aluminum. So it's a very powerful tool. It's not as easy as other 3D printers, of course, but it's very flexible.
Wow. So let me get a little closer view of it here. So these are all the same type of machines?
It's the same, yeah.
Okay.
This
So
is just a demonstration, so it's transparent.
So will they come in different colors, or are they just
white, black, and red?
Oh, okay. So what do we have going on this one? This is a standard FDM plastic?
Yeah.
Okay. And then over here, obviously it's pretty durable.
Yeah.
And then over here we are actually scanning, correct?
So this is just one of the 3 methods of scanning. You can scan with laser.
Okay.
You can scan with the optical camera, so you do a surface reconstruction with a complex algorithm on your computer.
Okay.
You can do probing, which is basically a touch digitizer.
Oh, you can do all 3 of those, huh?
Yeah, 3 methods. And you have FDM with PLA and ABS. And then
Okay,
you have
so it means
milling.
it has a heated bed. And then what do we got going on over here?
This is milling the Gale crater on Mars. It's a topographic map.
Oh, okay.
An high-resolution model. It's over 100 megabytes of G code, so it's very precise.
Wow. Okay.
The machine is working with 47 microns of resolution.
Wow. Very interesting. So I'll tell you what, give me your card, and then I'll shoot you an email, and maybe we can get you on to talk a little bit more without noise. That's pretty nice. So what are we looking at in price for this?
The price for the 3D printer is currently 1,009, excluding shipping.
So 1049?
Yeah.
Okay. Okay, that's very reasonable.
Yeah.
And what's the volume? How large of an object can I print?
So this is one of the biggest printing area on the market for this size. You can print basically up to the size of the building platform, up to the 24 centimeters in high. So I have measurements in millimeters.
That's fine. Go ahead.
Okay, so it's 232 by 230 by 241 millimeters.
Okay, that's decent.
And the box is 36 centimeters by 36 by 36. So you have a whopping 25% of build volume ratio.
Wow. Very impressive. And I noticed you're doing a circuit board there as well.
Yeah. So this is a Sanguino. It's an Arduino, and we mill it with a V-curve. So you can swap handles and
okay.
And you can also do for axis machining. Basically, the stock piece can rotate, and the milling bit can do all the axis. Okay, up to 4 axes.
Wow. Okay. Oh, pretty impressive.
Thanks.
Okay. I'd like to follow up on this, and then I will talk a little bit more in the upcoming weeks.
Sounds good.
Thank you. Wow. There is all kinds of exciting stuff here. All right, I'm heading back out, and hopefully I don't get brought back in again. But I am really surprised at the number of 3D fabrication machines and devices here. And I don't know if didn't seem like Chris seen or saw as many people as we did now. I know that there's some other 3D fabrication elsewhere that we'll have to look at. But it's just extensive. So what do we have here? Hi. Excuse me.
Hey, Mark.
What?
The headband is right there.
Oh, okay. Yes, please. Okay.
So this is from way back then. I didn't know it's been brewed now.
Hi, I'm from All Things 3D. You want to kind of tell me what's going on here a little bit?
Yeah, I'll talk to you. Give me 2 seconds.
Okay.
Let me just finish the
Sure.
So Mark basically, when I was in my office.
So let's see if I can figure it out a little bit. Looks like a engineering academy of some sort. So very interesting. When I grew up, all you had was military academies. So I'm glad to see that there's other things. So I'm assuming this is an application of multiple projects. Very, very interesting. Interesting. They look like they're sponsored by several people as well. Excuse me. Excuse me.
Sorry, just
that's
had to finish the
okay.
Conversation. So let me just tell you real quick.
Okay.
I'll give you a background. I'll kind of tell you where.
Sure. I'll go ahead and
headed.
use this as a backdrop then.
Have you come here to this project yet, or are you?
I
just
have
your
not.
First
First time,
introduction
yeah.
to it. Okay, so I'm going to give you a brief introduction.
Okay.
And then I would encourage you to go around and talk with the students who are involved in this, because I think they're really the ambassadors, and that's what we're trying to do.
Okay.
Okay. So my name is Amir Boshayer. I'm the director of the Dos Pueblos Engineering Academy.
Mhm.
We're a public high school in Goleta, California. It's a suburb of Santa Barbara. So we're about 300 miles south of where we are right now. And what we've created here is this is a mechatronics installation. The idea was that I run this program. I've been doing mechatronics and robotics for years. And I really wanted to get our students involved in a project that was authentic, where we would have the potential to actually turn it into not just an exhibit for MakerFaire, but a permanent exhibit at a location.
Oh.
So the idea is to get an exhibition space
Mhm.
with these types of things, and not just create widgets and things that the kids are proud of, but then all go sit in their closet.
Yeah.
I wanted to have like a life beyond that. So what we've done is we've created this concept, and the idea that I had was we'd have a carousel with all of these different sectors, so that I could engage 60 students in my senior class for the capstone. 4 students work on each sector. The
Mhm.
sectors circumscribe the central nervous system, which is over in this tent over here.
Okay.
And then 4 kids per sector, and each kid has a project on the sector.
Oh.
The project is a physics or engineering concept that is meant to be mechatronically controlled to teach the concept. And so ultimately what's going to happen when we're done, right now we don't have it all put together because there'd be too many people in the tent. We have all these students with their sectors around, and then we have 6 or 7 of the sectors installed on the carousel so that people can get the overall vision of what the piece will look like when it's actually all assembled together. So what I'd like you to do basically is, at this point, I think the best thing to do is to go in there and see it, get
Okay.
a sense of it, and then you can talk to the students both inside and outside and get a sense of how the whole thing goes together. But
Sounds good.
that's what it is. So thank you.
Great. Well, great work on your part.
Thank you. I appreciate it.
Hi, you have a moment to tell me what you've got going on here?
This whole thing?
Well, actually, I got an overview from your principal, but yeah, specifically on what you're working on over here.
So this is my sector, and basically this is demonstrating waves, and this is all about waves and simple oscillators. So basically, should I run the project?
No, go ahead.
Okay, yeah. So basically, the top project is a chaotic pendulum, which basically shows chaos theory, and it's 2 pendulums, and
Go ahead and bring it up.
when they're based off each other, they create you can't predict the outcome based upon the input. So that's the first one, and then the second one is my project, and I basically hung pendulums at various lengths in order to create a sine wave pattern. So they offset each other. The period lengths offset each other to create a sine wave, and then the third down here is 2 motors that are connected to various camshafts, and those camshafts control the heights of these rods here. And those rods are hooked up obviously to these like that. And then when this motor is initiated, the wave goes through in this direction. And when this motor is initiated, it goes in this direction. So when both are turned on, you can see the superposition of both waves together. And it's basically a 3D representation of sine waves. And then this one at the bottom here, this is an inverted pendulum. And basically an encoder is right here, and that detects the angle of the rod that's hanging off. And this one, there's another encoder down here. And it tells the cart, based upon the angle of the rod, how far it needs to move to keep this upright. So when this runs, it swings the rod up, catches it, and then like goes side to side in order to keep the rod up. And it can combat the wind. It can do all these things. So yeah,
no,
that's our sector.
Very neat. So one of the things that was mentioned to me, go ahead and bring it to your mic, is I've noticed that they're very well polished. It's not just like an ad hoc piece of equipment. And what he mentioned is that these are going to go on permanent display. So did you have a hand in the actual design of the whole case and everything as well?
Yeah. One person from the sector is in charge of CADing the sector layout, and then we all CAD up our various projects. We all have 1/4 of the sector is our part, and for example, I programmed or also computer designed this. And basically, yeah, just through that, we learn all about the design process and just go from inspiration.
So if you don't mind me asking, what grade are you in?
I am senior in high school.
Okay. So obviously, we've come a long way since when I was a senior in high school.
Yes.
So it's really neat that this is going on. Now, this is an academy, correct?
Yes, it is.
So my experience also is that you had military academy. So what makes this different?
What makes this different is from a military academy. So like ROP programs and stuff. So this is somewhat like an ROP program. So basically we apply our 8th grade year as we come into school, and basically we either are accepted, declined, dependent on how well-rounded of a student, and basically all these various things. So basically we're selected and based upon our interest in the program and our knowledge of the subjects. So yeah.
Well, obviously it's paying off.
Yeah, it's definitely
cool.
paying off.
So let's see. What do you have a website?
I actually don't know. We're connected through our high schools, which was Pueblo's high school.
All right. Well, let me take a picture of this so I don't forget it, and I'll look you up.
All right.
Great work, guys. Thanks. Oh, excuse me. I'm sorry. Yeah. Well, I have a co-host, which is this guy, but he had a family emergency, so I'm doing it all by myself. But I set it up to do that. I went to CES like this. It's the only one that was doing live streaming. Oh yeah, this is all live. In fact, if you go out right now, you can watch it. You're welcome. There's another Tesla. Obviously, if you're not familiar with Tesla coils, I'm probably thinking you are. What makes them impressive is the way that they create a large spark. It can be controlled. Tesla coil, as you know, I think there's a couple of movies that have demonstrated how cool they are. They're also not that difficult to engineer, but this one is well made. Obviously, it doesn't seem to be running, but one of the things that I'm really impressed with is the engineering that went into making this. Obviously, as the director identified, they put a lot of effort to try and make this into a permanent display, and it shows. So I'm going to kind of move on and see what else I can cover before I end today. So let's kind of move on and see what else we've got out here. So this looks like the mobile tech shop. We also covered them at Real 2015. Must be local. I think Chris knew the guy personally. So let's see what else we have. Yeah, let's go in this direction. Maybe cover another. Let's go into this building. I think I was in here the other day. That's right. The are you local? It's a little bit not what that's all. So it's not tell me a little bit about it. Get up close and then talk to you. A little bit closer. Okay. Going good.
All right. I have research, the master class, rolling out, and I'm out of wood.
Very cool. This is what they metal. Like metal.
Oh yeah, I used the process that I came up for the paint. Here's another one I did. The cat. And this is that's the very first bottle.
Wow. It looks steampunk a little bit.
Yeah, I have a steampunk section, but I'm sold out of it currently.
Pretty. I have a website. I'm going to make it.
Yeah, Dash.
Great. Well, thank you very much.
Thank you.
Well, right now we went live. We're on Google on air. So, yeah. Yeah. So I have the system set up with a Windows 10. It's the only thing that I'm doing. Then I archive with an HD camera, and then I also have a 360 panoramic camera. Shut down and it archives to YouTube.